Welcome to the channel, guys. This is NEET Chemistry CRUX. In this video, we'll be starting structure of atom. It's the first chapter of the crash course for NEET 2024. It's the first chapter, and we'll be starting with structure of atom. After this, in every video we'll be discussing one concept, and in this video we'll be discussing atomic number, isotopes, isobars. Also, we'll be discussing what are isotones and what are isoelectronics, right? So we'll be discussing this first topic over here. After this, in the next video, we'll be discussing concept of shells and subshells, and also then the subsequent topics will be seen in subsequent videos. All right. So let's start. First of all, for NEET, from NEET perspective, this atomic structure, it's very important chapter. Atomic structure. All right. Atomic structure. So in this chapter, almost from this chapter 2 to 3 questions are asked every year, 2 or 3 questions, so you'll be getting 12 marks maximum out of it, and that's a huge number. It's a easy chapter and you can easily score these 12 marks out of it. Only you have to do is that you have to go with these topics clearly that are mentioned in the syllabus. So today let's take the first topic. That's the isotopes. That's first of all atomic number, then isotopes, and at last we'll be seeing at isobars. Now you know that atomic number here. All right. Now, in order to understand these concepts, what you have to understand is that an atom, it consists of three fundamental particles. All right. Those are electrons, protons, and neutrons. All right. So these are the three fundamental particles that make up the atom. I know there are almost 120 subatomic particles that have been discovered. There is meson, pi boson, there's pi meson, there is boson, there is Higgs boson, there are many other, neutrino, antineutrino. All right, these are dealt with in nuclear chemistry and not here in the structure of atom. These are the particles that constitute actually the atom, and out of these two, they are called nucleons. Protons and neutrons, they are called nucleons. Why? Because they are found in the nucleus, and this electron, it's found outside the nucleus. All right. So in order to understand this concept of atomic number, you need to understand the basic things that are there. Every atom, that has a specific number of protons in its nucleus. It's just, let me make it. All right. So every atom is specified by the number of protons that are present here in its nucleus. For example, if there are 2 protons, we will say it's helium. If there are 3 protons, we will say it's lithium. If there are 4 protons, we will say it's beryllium. All right. Or if there is a single proton, we will say it's hydrogen. All right. So these are the things that you need to understand. Every atom is specified by the number of protons that are present in the nucleus. So, and this also forms the basis of periodic law, right? How we classify atoms. So here, what happens? What is the atomic number then? It's the number of protons present in the nucleus. All right. Number of protons present in the nucleus. But apart from this, we can also say that for a neutral atom, we can say atomic number is also equal to the number of electrons. Why? Because the number of electrons in a neutral atom is equal to number of protons. All right. But for charged species, like which are ions, like cations and anions, we cannot say that atomic number is the number of electrons, because there is imbalance in the number of protons in the and the electrons, right? So you can say that atomic number is the number of protons present in the nucleus of an atom, or you can say that atomic number is the number of electrons present in a neutral atom. All right, so that's the concept of atomic number. After this atomic number, in order to understand isotopes and isobars, you need to understand the concept of mass number. Let me say you that in a nucleus where there are nucleons, that is protons, and neutrons, let me draw them with red, and neutrons, if this is a nucleus, the nucleons give the atom its mass. All right. The electrons, on the other hand, which are present outside the nucleus in the shells, all right. So these electrons, let me draw them with green here. These electrons, they do not contribute to the mass of the electron, all right, to the of the atom. So what is mass number? Mass number is the number of nucleons. Mass number can be simply written as number of protons plus number of neutrons. Here you can see that protons and neutrons, they are only contributing to the mass of the atom. And why electrons are not contributing to the mass of the atom? Because their mass is very negligible. If you want to, many a times a question can be asked on the mass of these species. So you can say that electrons, they are the ones which are least massed among the three fundamental particles. Then comes the turn of the protons. There comes the turn of the protons, which have the mass which is further less than neutron. It's the exact order. And in general scenario, what we say is that these electrons, they are of negligible mass, and proton mass is similar to neutron mass. All right, neutron mass. So here you can understand that actual order is this and the approximate order is this. All right. So the mass of electron, it's about 9.1 1 into 10 to the power minus 31 kg. All right. And at the same time, mass of proton, it's 1.67 into 10 to the power minus 27 kgs. All right. So you can see there's a difference of 10 to the power 4, right, between the two. The mass of neutron is also almost the same. There's, however, a difference of like this, 1.6738, something like that. I don't know the exact number over here. You can verify that. So this is the difference actually, into 10 to the power 27 minus 27, all right, kgs. So here you got to know about the mass of these particles, fundamental particles. Now what is mass number? Mass number, because this electronic mass, it's way too small than these two, would not consider it in the mass number. In the mass number, we say mass number is the number of protons and is the number of protons and neutrons, protons plus neutrons. Fine. So after this, after understanding mass number, you can now go with isotopes and isobars. So what are isotopes and isobars? Let us discuss that, right? If you see an atom, for example, let us take X. First of all, let me show you the representation of atom. An atom is represented like this, X, X. All right, there are two ways of representing it. The mass number, the atomic number goes here in the subscript, all right, A. And the mass number, it can be written either over here, mass number, or either over here, all right. So these are the two ways of representing an atom. So after knowing the representation of the atom, you can now understand what are isotopes and isobars. If there are two atoms, for example, X and Y, all right, and let's first of all go with isotopes. If there are two atoms of same species, that is X and X, their atomic number is same, A and A, but they vary in their mass number. Let us say its mass number is P and its mass number is Q, then they are called isotopes. So what are isotopes? Isotopes are the species in which atomic number is same. Atomic number is same, but mass number is different. Mass number is different. All right. This is isotopes. What are isobars? If we take if we take two atoms of two different, species, for example, X and Y. For example, X and Y. The atomic number of X is A and that of Y is B, but the mass number of X is P and also the mass number of Y is P, then these species are isobars. So what are isobars? Isobars are the species in which atomic number is not same. All right, atomic number is not same, but mass number is same. So these are the two terms that you need to understand as per the NEET syllabus is concerned, right? Isotopes, they have same atomic number but different mass number. On the other hand, the isobars, they have different atomic number but same mass number. Let's give examples of each. Fine. For example, there is hydrogen. The atomic number of hydrogen is 1, so we'll be writing 1 in the subscript of each of these representations, right? But what you see is that the mass number of protium is 1. On the other hand, the second isotope of hydrogen has mass number of 2, which is the deuterium, and the third isotope of hydrogen has mass of 3, which is called tritium. All right. So these are the three isotopes of hydrogen. What happens here is that the atomic number is same, 1, 1 and 1, but mass number is different. All right, 1, 2 and 3. So these are isotopes of H. In the same way, we can say carbon. It has 6 carbon, it has 6 atomic number, but sometimes it has a mass number, one isotope has a mass number of 12. On the other hand, the other isotope has a mass number of 14. So these are two isotopes of carbon, right? In the same way, there are isotopes of many other species as well. Like there is chlorine, which has two isotopes as well, chlorine and chlorine. Fine. Atomic number of chlorine is 17, so 17 here. One isotope has a mass number of 35. On the other hand, this isotope has a mass number of 37. All right. So these are the two isotopes of chlorine. Here you can understand what isotopes are. These are species with same atomic number but different mass number. Now let's take the example of isobars. What are isobars? For example, there's a species like argon. All right, argon is there. Its atomic number is 18, and potassium, its atomic number is 19. But on the other hand, the mass number of argon is 40 and the mass number of potassium is 40. So both of them, you can see, both of them have same mass number, 40 and 40. So they will be called as isobars. Why? Isobars are the species which have different atomic number but same mass number. That's how you deal with these things, right? After this comes the turn off. Let's also go with some most terms that are important as per NEET is concerned. There is a concept called isoelectronics. It has very much applications in coordination compounds, coordination chemistry. It has in periodicity. So isoelectronics are very important from that point of view. So you should be knowing what isoelectronics are. Isoelectronics, it is the name itself. Iso means same, and electronics means number of electrons. All right, same number of electrons. In the same way, you can also go through the word itself over here. Iso means same and bar means weight. There are also isotopes. Where it is? Isotopes. Where did I write that? All right, let me write it here. Isotopes. Iso means same, and topes is another name of protons. All right, they have same protons or same atomic number. Fine. So these are isotopes. Then there comes isobars. Now there is isoelectronics. For example, let's take an example of it. For example, there is Mg dipositive. A neutral Mg will have 12 protons and 12 electrons. But Mg dipositive, it will have only 10 electrons. Sorry, it will have only 10 electrons, right? On the other hand, if we take Al3 positive, a neutral one will contain 13 protons and 13 electrons. But since it has 3 positive, it will lose 3 of them and it will become 10 electrons, right? Here you can see these both species, Mg2 positive and Al3 positive, they have 10 electrons each. So they will be called as isoelectronics. Isoelectronics. That's it about the first few topics of, as mentioned in the NEET syllabus. We have covered atomic number, we have covered isotopes, we have covered isobars, and also we have covered isoelectronics. So after this, in the second video, we'll be discussing about concept of shells and subshells. In the third video, like this, we'll be making other videos as well on all the topics. And in this way, this chapter, that's atomic structure, it will be covered in 10 to 12 days. All right. Make sure to subscribe to the channel in order to get more videos like this. Thank you for watching.